Hello, everyone. Welcome to Avocado Sprint 64 release meeting. We'll be talking about the stuff that went on during the sprint and that will culminate in Avocado version 64. I'd like to give a formal welcome to Caio, who is now part of the team. So you may be seeing him around, starting with this meeting. And to be honest, next sprint is already his responsibility to facilitate. So it's kind of a nice welcome. And so let me share my screen as always, and let's go through the Trello board and briefly describe the work we have done and what's gonna make Avocado 64. So there's been quite some work in the VM image Avocado library. So for those who don't know, this is a library that allows users to get one operating system cloud ready image of various Linux distributions. On this one card, we had a way to allow users to abstract from distribution and architecture, distribution names and architecture names used by those distros, which are pretty much internal details. So as one example, Fedora calls PowerPC 64 as lays them out in an area called Fedora secondary. To users, it doesn't matter much. So this allows people to just do get me a Fedora Power PPC64 image, and we will understand what the user wants. The same thing for architecture names, such as ARC64, which on some distros, they are called ARM64 instead. So this just makes the references to distros more common, and then users don't have to deal with how distributions actually lay those files on their servers or call their architectures and so on. Another work that we have added, it's a brand new module on this release. It is intended to be used with the VM image library, like optionally with the VM image library. It introduces this Cloud Init module. What it allows you is to give an operating system image that has support for Cloud Init. You can create a Cloud Init configuration ISO file that allows you to basically prepare the image with some important configurations such as instance ID that you can use to uniquely identify that instance, and you can set credentials for authentication into that newly spawned instance. One other interesting aspect of this library is that it brings a so-called phone home server. This allows the user to ask the operating system image to call back and let the user know that the image has successfully initialized. So it can be used for a variety of purposes, including just the functional check that the image has fully booted, or it could be used for progressing in a given test, knowing that the operating system is up. So you could be playing with another live operating system that you know has fully booted. So it's a brand new module. It's intended to be used alongside with PM image. And we have internally, I can say that I have tested it with a number of distros that ship Cloud Init build team, and it seems to work for all of those. Next, we have been dealing with a number of false positives in our Travis CI. It looks like depending on the specific version of the Python interpreter, pylint, inspect, and whatnot, we end up having those false positives saying that the given name does not exist on a given module during the lint step of inspect. We tried to understand what causes this by sending a number of pull requests, improving, updating the versions of the modules we used, and so on. The culmination of this work was this pull request, which basically sets a default for pylint that the parallel level is going to be 1 when this is run on Travis. When it's not run on Travis, it's going to use the default, so people doing make check on their local systems will still run those in parallel by default, which usually works. The problem is usually limited to Travis, so it makes sense to have slower lint checks, but dependable ones on Travis CI. So this is not like a permanent fix, but it is a workaround that we are going to be using until we can really pinpoint why inspect lint and possibly pylint under the Travis provided images behave sometimes like this. We had some fixes on the partition library to make it work on Python 3. And while checking that, we also found a few other issues that were worth fixing. Basically, the most pressing one on this commit was to deal with systems that do not have LSOF. So basically, the partition module has a feature that allows one to attempt to forceful unmount a given partition. And it does that by trying to list the processes that are using a given partition using the LSOF tool. But the LSOF tool is not that standard on Linux systems. Most of the time it is there, but it's pretty common to not be there. So on this pull request, we adapt to situations where LSOF is not existent, and we actually signal a partition error on those circumstances. So a couple of testers were added, in which cases we check what happens if LSOF exists or does not exist, and we make sure that the partition error is raised if LSOF does not exist. So some improvements and fixes on partition module. So as part of the enabling of warnings and fixing of the checks on Travis, Kyle actually found out an issue on pylint, and he reported that upstream, and the fix was already merged. So that was an interesting side effect of the work. Well done here, Kyle. And any comments you wanna drop on this?
Just the most important thing in this PR, I think the change was really simple, but the good part is that I could write more tests for pylint, so we could contribute increasing the coverage percentage of pylint,
Nice.
and that was really good.
Cool. Well done. All right. Next one was a fix that was part of the warnings enabled. One of the many warnings that were enabled on our lint checks. So this one replaced a map filter for a comprehension. So yeah, so we had a map in a lambda function, and we just replaced it by a comprehension, and it was on the external Spark module. Fair enough. On this sprint, we also introduced support on the ISO 9660 module for creating images. This was in part a requirement of the Cloud Init module that needs to create ISO libraries. And the interesting part is, possibly I should start with this first, because it makes chronological sense. So getting back a little bit before that idea of Cloud Init needing to create ISO images, um, we needed to create that in a programmatic way. And if people that are familiar with both Avocado and Avocado VT, that is not a new requirement. So Avocado VT, for instance, creates ISO files for a number of situations. Not only, but the most common one is the creation of ISO files containing Kickstart um, configuration that will pass to operating system installations. But that has always been done manually. So people would attempt to find tools like make ISOFS, Gen ISO image, and those types of tools, and they would then attempt to create the ISO files. So in an attempt to make things more consistent, we try to add support for creating ISO files as well as reading from them, which is already present in the ISO 9660 module. And this change builds on top of this previous one, which was the addition of a PyCD lib backend. PyCD lib backend is a pure Python library that can create ISO images and can read from them. So this first work actually adds support for this backend and support for reading, copying, which is like the basic interfaces that are present for all of the other backends. So this is a brand new backend. The positive thing about this is that we introduce this dependency as mandatory on our CI checks, and that means that at least this part of the the checks, like the basic workflow, it's going to be called for this library no matter what. So even if the system does not have any of the external tools, we'll still make sure that some of those tests are going to be run. So when we added this, we opened up support for coming up with support for creating and not only reading ISO files. To do that in a consistent way, we had to introduce a mechanism of capabilities. So now we have a new optional parameter to ISO 9660, which is capabilities. So if you provide the capabilities that you know you need from one of those backends, you only get one backend if we have one that can actually fulfill that. So the Cloud Init module itself, which we talked about before, it's a user of this API. So it requires a backend that has support for creating and writing archives. And we have a bunch of tests here on different scenarios with different backends enabled and disabled. So this is a feature in itself, but also a feature that came out of the necessity of the Cloud Init library. Next was the update of PyLint. So this is pretty basic, mostly internal stuff. On our Travis CI checks as part of the hunt for the false positives, we decided to go ahead and bump the versions, the pinned versions that we were using for PEP8, Inspector, and PyLint. So we would have more recent coverage on our code. Next, we detected that on newer Python versions, so anything above 3.7, we don't have the platform.dist function anymore. So actually this was deprecated as way back as 2.6, and it has been kept up to this point. So we decided to go ahead and remove a probe that we have on our UTools distro library called the standard lib probe. This probe, it's actually registered last. So we use our own probes before, and then we fall back into that. But given that it has been deprecated for so long, it's going to be removed. We decided to just remove it and go with our own probes instead. There is one debatable aspect here, which is the Python standard library points people to the distro module on pip, which is pretty comprehensive. And maybe at some time we'll have to make a decision about delegating that to another module or not. So far, it seems like our users are doing okay with this, and it's stable. So let's see how we'll respond to that. This is mostly a card that interests myself and maybe other people out there. So I was trying to make use of the contrib script that Lukash developed that allows you to check Avocado itself, run the make checks, the self tests, and post those results to GitHub using the GitHub API. I tried using it before, and I did not succeed at it. And after some time, I gave it another try, and I noticed that the origin address that I was using on my repo, even though it was valid, it was not something that the API, the GitHub API, was willing to accept as part of the API calls to post the commit statuses. So this was fixed, and just a note that if people have something similar to my configuration, they should probably change their origin. Downloading files should print information such as file size. This is another thing we worked on this sprint. It's pretty minor, but it has a real use case. So sometimes you have a test that fetches data from a location, which is a fixed location, but the content can actually change. So either the file can be updated, or the directory itself, it's something like latest, and you always grab the latest build of something. So if one job fails, you would probably want to know why, and one way to understand the differences is to know the date, time, size of the file you're using as part of your test. So we went ahead and we added that information into the log if it is available. So users of the asset fetcher, those higher level utilities on Avocado will automatically make use of this extended logging of downloaded files. Next, it's another small improvement to the VM image library. So basically, the VM image library will use by default the same directory in which the base image is to create the snapshot, usually a temporary file that you'll be playing with and then you discard. So this has the negative aspect of, by default, keeping those temporary files in the cache directory. And most often than not, this is not what we want. So this change adds another parameter called snapshot dir. And this is where the snapshot file, the temporary file, will usually will be put. So tests can then choose to keep the base image on the cache dir, so they will not be downloaded again. But then the transient, the temporary image will be put somewhere else, such as the test work dir, which will be removed along the test. So this is a small usability improvement to VM image. During the Python 3 porting work, we noticed that a lot of the tooling that we were using needed a Python 3 version. Basically, this was about the cyclical checks. The cyclical checks is about checking if we don't have one module importing from another in a cyclical way. We were using a bunch of tools such as Snakefoot, NetworkX, PyGraphviz, and PyDot. So a whole bunch of tools to implement this check. And most of those are not available in Python 3. So we needed a replacement. It seems that the replacement is pretty easy. It is available in PyLint itself. So we just enabled that for both Python 2 and 3. And we got rid of all that code. I always like removing code. Next one is also a change to VM image. It is pretty much an internal change, shouldn't affect any users, but it's we had some compression handling code, decompression handling code that was on the VM image library, and we moved it back to archive instead. I think beyond this, we also, yes, we had some Python 3 fixes. We noticed that we were not at all loading this module on Python 3, which is a shame. The answer is still a little bit of a shame because I only managed to have time to create a really basic unit test, but at least now the module is loaded on Python 3 and it's tested on Python 3 as well. And we do have a card to actually improve the testing on the VM image library. The next one is about the pure Python backend for ISO 9660, which we already talked about. Next one was a packaging work for the CIT plugin, and we'll talk about the CIT varianter plugin next, which is this card. So long story short, this is somewhat of a milestone for us. We have been trying and playing with the concept of pairwise, also known as combinatorial independent testing, for a while. The planets align in the right order, and we got a contribution from actually a collaboration set up with the Prague Technical University, and they developed a plugin for Avocado that actually delivers that. So this is the combined work of Prague University, Amador, and myself in various different iterations. Lukash reviewed the code. But anyway, it culminated, people are happy about it, it culminated in this feature. And basically, this feature is about, let me share the screen. Sure. Just setting up the latest Avocado here. And when we do Avocado plugins, we should now have a new plugin in our varianter section. So that is the CIT varianter. The CIT varianter, it takes a number of options pretty similar to the picked plugin. So if we do variants and help, you should see options that resemble picked. So we have CIT parameter file and CIT order of combinations. We have one example configuration file that can show you the generated combinations. So if we do CIT parameter file, we have one example file on varianter CIT called params.ini. Let me just go ahead and show this. So basically, we have 5 sections. So one is color, second is shape, then state, material, and coding. And we have a different number of parameters on each one. So if we just do the standard CIT parameter file arguments, this is what we get. We get 14 variants, um, which by default has an order of 2. And that means that each pair of unique combination of those parameter types, so each one of those keys, it's guaranteed to be at least in one of the tests on the generated variants. So using the pairwise terminology, the test suite that is generated, in our case, the number of, like the list of variants, will contain at least one instance of a combination of 2 unique things. So you should be able to find at least one, let's say, cathodic and gold combination listed there. So let's see if that is true. So yeah, we have a gold and cathodic here. Just pick any other one. So let's say circle and liquid. So let's see, circle and liquid is here. And that's the whole point. Like the premise here is that parameters, when combined with another unique parameters, they actually cause most of the code paths in the software to be executed. So there is no need to actually run all of them. But if you do need to extend the coverage, you could do something like CIT order, actually order of combinations. So CIT order of combinations equals 3, and that's gonna expand that to make sure that each 3 unique parameters you can name is listed at least once. So now we have 49 different combinations, and you can go like from 2 to pretty much the maximum number of combinations, which in this case is 5. So with 5 we have 216. If I think 5 is the maximum here. Yeah. So 216 is the maximum. Yeah, it's a pretty interesting tool. Some external tools actually implement combinatorial independent testing, and Avocado is lucky enough to be at least the only test runner that I am aware of that actually has that built in. So it is an optional plugin because of the architecture of Avocado, but it's built in as part of the standard Avocado. So pretty exciting stuff. Next one was a bug that we fixed in our own scripts. So on Travis, we had this issue where depending on the version of Python, on Python 3.4 specifically, if the module was failed to be loaded instead of had a failure on the test, that would not be caught by our scripts, and we fixed that. Our packaging master and colleague Merlin, he contributed this change, which enabled pretty much all the plugins on Python 3 versions of the packages. So now you should be able to see all the plugins here. So results, upload, runner VM, Docker, and varianter, YAML to MOOCs, and all those plugins to Python 3 as well, which is a good thing. And early in the sprint, we faced a number of build issues on Fedora 29. Some of those issues were actually directly tied to Fedora 29. Things like Python as an executable not being available anymore by default. But there are also things which are caused by the bump of Python version. So we have Python 3.7 on whole height on Fedora 29, and this has called for some changes in our own code. So we should be ready whenever Fedora 29 or other distros with Python 3.7 actually start. We Avocado starts to be run on those scenarios. So this was pretty productive sprint. Lots of new features, new modules. But we also had some stuff that it's still in progress. There are new tasks that they're actually old tasks that received a lot of changes. This one, it's really worth talking about. So this was a pretty old card that we acted every now and then. So we what the goal that we have here is to enable all the warnings in our inspect link checks and actually only whitelist the ones we feel that have to be disabled in the code itself. So Kaio has worked a lot on this, and you can see that most of the warnings are already taken care of. We had a number of pull requests, and we are pretty close to enabling all warnings. Do you want to comment on this, Kaio?
Just a quick comment. My approach was enabling all the checks that doesn't require a lot of work to be checked. So in this step, we already can check and avoid a lot of lint errors.
Mm-hmm.
And now what is left is just the checks that need some work in the code base. Probably some of these checks will be in the whitelist, in the future whitelist that will put in the check, but some others checks need to be fixed. So I'm working these checks right now. Some of them are not is not so trivial, but it's really important, and I think we already have a point where we can avoid a lot of errors. So we already have done some improvements, and I think in this next sprint, of course, all checks will be enabled.
Yeah, I have the feeling that we are pretty close. I mean, you don't have to be a genius just by looking at this list. You can see that we are pretty close. And yeah, it's a pretty good thing because even though Python is one of the languages that most people have like the capacity of keeping a good subset of the language and best practices like in memory cache, it's still impossible to remember it all. So those warnings are really good. All right. Next one was the addition of an OpenSUSE provider for the VM image library. So basically, VM image library has a number of backends of providers, image providers, and those image providers, they basically crawl the HTML pages and they look for the latest images. It is the case that OpenSUSE has a pretty awkward layout scheme, not only the directory layout scheme, but the naming scheme as well. So just to give one brief example, Leap 42 is older than Leap 15. So I think that says it all. It's a really different naming mechanism. So I actually have a prototype of this, but it needs some tweaks and improvements before we send it. So hopefully on the next version we will let people fetch and have images for OpenSUSE as well. Um, this is an Avocado VT change that is still in progress. It's basically related to attempting to fetch log files on case of failures. It's a feature that is based on the console feature. So when networking is not enabled, for instance, Avocado VT will try with this change to fetch files of a certain pattern that may be log files installation related to installation. There were a few issues because it looks like this only works on a few combinations of architectures, and I was not working on one of those, so my results were different than the others. Um, so it needs another round of review using a different set of architectures and versions. Uh, yeah. So next one is a feature which we have discussed but not send public proof of concept or PR on this, but it's basically related to attempting to transparently uncompress archives if necessary. It was driven by the fact that sometimes people put archives or images on the web that get referenced by a number of tests or even some other types of code. And sometimes the file name does not really match the archive type. And it's usually needed on our part to detect what's there instead of requesting the user to rename that because it would break a lot of references. So it's something we still work on. One feature that we are also working on is the recursive by default. This is an interesting change that has as the latest incarnation, latest update, the this one pull request. So we already had like something like 2 or 3 pull commits merged. This brings another 3 or 4. So we're waiting on the author, on Lukash, who is not online for this week and the next one, to be back and resume this work. Uh, Maybe I failed to define what this is about. So basically, the Avocado test loader, it does not run Python code, so it attempts to understand test classes and test methods by doing a syntactic analysis only. And uh, when there are different levels of inheritance, we required people to use the recursive tag, and this change actually abolishes the recursive tag and makes it a default feature. So in theory, it would behave more like traditional Python code without any extra requirements, while still not loading Python code during inspection. Next one is this card basically exists because of another issue on YAML to MOOCs, which was being worked on here, but then was temporarily halted. So this card, consequently, it's also paused for this moment. And the next set of cards are basically dormant. We have been working on other stuff and not actively on those, but they're related to parameters. So we need a simplified way of passing parameters to tests and not really abusing mux inject. This requires some deeper changes in Avocado code, and compatibility is a bit tricky. But we are working on this to have a way to just pass parameters to tests without involving the variance layer. Picked, it's something that we already have a plugin to use as a varianter backend, as a varianter plugin, but we also want to have picked as a package available on Linux distros such as Fedora. So this is what these tasks are about. And finally, this one is about making Avocado VT easily installable by Python standard means, such as python setup.py install. Okay, so this is the end of Sprint 64. This is what is done. We have run the test plan. We are good there, and we should be releasing, pushing out the release notes and the packages later today, and announcing on the mailing list as well. So for now, what we have to do is to create a new board, which is going to be, actually this becomes work in progress 65, which needs a name. Sprint backlog 65, which, oops, which also needs a name. Do we already have a name or not?
Not yet. I will research some.
All right. And we have done 65 right here. So just a quick, since we're now talking about the next sprint, we already have a few stuff to take care that is already in the work in progress for 65, and the sprint backlog has a number of minor issues, like those checks for warnings, move tests to the plugins, drop the use of libraries that are dead, such as Pistache, and a few which I consider interesting ones. I'm actually interested by it. So we should be planning to add continuous RPM builds by using the Fedora Copper instance and hooking that up into GitHub. And if time allows, we'll be working on this, which is the test loader rewrite using the new plugin architecture. Let's see what time will allows us to do. And one thing that we should notice is that a lot of the work on this sprint might actually get shifted or adjusted based on the work the same team of people is doing on what we call Avocado QEMU, which is a set of functional tests for QEMU itself on on the upstream QEMU project. So you may be able to see new cards coming up, reflecting the changes of that work. Other than that, I think this is about it. Do you have any other remarks, Kyle?
No, just thank you for the welcome, and I hope to contribute really, really well in the next sprint.
Nice. Thanks so much for your work so far, and I'll see you around. And thanks, whoever is watching this. Bye bye.